In the last set of notes, we talked about compounds. And for example, we talked about NaCl, salt, sodium and chlorine coming together and being bonded. Compounds are formed when elements are chemically combined. And to be chemically combined, they have what's called a chemical bond. And that chemical bond is a force that joins the atoms of that compound. So the sodium and the chlorine are bonded together by a force and holds them into that compound. What's really interesting is that bond holds energy. So if we break that bond, we release energy, and we're going to see that come into play as we talk about cellular energy later on in the semester, that we actually do break those bonds and release energy for the cells to use. For these chemical bonds, you need to know that atoms need to have their outer energy level filled at all times to be stable. Okay, so if they're floating around and their outer energy level is not stable, then, or it's not filled, then they're not stable, and they're trying to find some way to become stable. They do this by bonding with other atoms that are also unstable. When we're talking about those outer energy levels, we're discussing the levels of electrons. And so just kind of review with you again that the first level needs 2 electrons, the second level needs 8 electrons, and the third level either needs 8 or 18 electrons to be considered filled and stable. There are 3 types of bonds, but we're only going to cover 2 in these notes. We're going to cover covalent bonds and ionic bonds. Covalent bonds occur when atoms share electrons. They do this so they can become stable, and this is a very strong bond. Some examples, carbon uses covalent bonds. It can form 4 covalent bonds. Now, I want you to draw a picture down there on the bottom. I'm going to show you the picture on the screen in just a second. This is of CH4. This is methane. Okay, CH4 means there is 1 carbon atom bonded with 4 hydrogen atoms. Okay, so the reason why carbon can form 4 covalent bonds is because on its outer energy level, there are only 4 electrons. See, the blue electrons that are drawn in here are the carbon electrons. So see, this whole thing right here is carbon. The blue is all carbon. This is a carbon electron, this one, and this one. It only has 4 on the outer level. See, there's 2 on the inner level right here. There's 4 on the outer level, and it needs 8. So that's why it says it can form 4 covalent bonds, because hydrogen right here, they're all the orange guys, they have 1 electron. There's only 1 energy level on hydrogen, so it needs 2 to be stable. So what happens is carbon shares its extra electron right here, hydrogen shares its extra electron right there, and everybody's happy. Now hydrogen has the full 2 electrons that it needs to be stable. Once you combine all the other hydrogens and carbon, then we have 4 bonds going on. So let's count and make sure that everybody is full and stable. Hydrogen needs 2 on this ring. You see there's 1, 2. This hydrogen has 1, 2, 1, 2, and 1, 2. Carbon has 2 electrons on its inner level, so on the outer level it needs 8. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. Carbon is now full and stable. I want you to take a second, draw this exactly how it's posted there on the screen. Please also label that this is methane and put the chemical formula right there, the CH4. Also label where each of the shared electrons are, and that make note that that is a covalent bond. Once you finish drawing all of that, then you can come back to the video. Okay, on the next page, it's talking about water. Water is another compound that uses covalent bonds. Water is H2O. That means there are 2 hydrogens and 1 oxygen. And you're going to draw a picture. This is a very simple drawing of that compound. We have oxygen here in the center, and we have 2 hydrogens. Hydrogen, just like before, only has 1 electron to share. So there's 1 electron to share here, 1 electron to share here. Oxygen has 2 electrons on its inner level. On its outer level, it only has 6 electrons. It needs 8 electrons, so it has 2 open spots to share with hydrogen. That's why we have 2 hydrogens. So now that hydrogen has shared its electron and oxygen has shared its electron, let's count and make sure that everybody is full. Hydrogen only has 1 level, so it needs 2 electrons. Let's make sure there are 2 electrons on this level. 1, 2. Follow the line here. 1, 2. For oxygen, there is 1 level that has 2 electrons already. The second level needs 8. Let's check and make sure there are 8 electrons now. 1, 2, 3, 4, 5, 6, 7, 8. Everyone is stable now. Those bonds have been formed, and this is a stable compound. Please take a second, finish drawing. You can color code like the last one was and have the electrons showed who's sharing what. The next type of bond that we're going to talk about is an ionic bond. An ionic bond is when electrons are transferred from one atom to another. This is just like covalent bonds, where the atoms now will have full outer energy levels, and this is the strongest kind of bond. Where covalent bonds shared electrons, this one is actually transferring. They are giving electrons to each other. In an ionic bond, you see ions. Ions are a charged atom. They're either going to be positively charged or negatively charged. When an atom loses an electron, it becomes a positive ion. Now remember, in the ionic bonds, they are actually giving electrons away, or they're getting electrons. It's not sharing anymore. They're actually passing them back and forth. So that's why we have ions. Imagine it like a balance. When a balance has even weight on both sides, it's nice and even and neutral. If you take away an item from one side, then the other side is going to move. That's what's happening here. When an atom loses an electron, it becomes positively charged. The opposite is also correct. When an atom gains an electron, it becomes negatively charged. This is important because negative and positive is attracted to each other. That's how the ionic bond occurs, is when there's a positive ion and a negative ion, they're going to attract to each other like a magnet and create that bond. So in your notes, you're going to draw how sodium and chlorine form an ionic bond. I'm going to put a picture up for you now. I want you to take a second, pause the video, draw everything and label everything you see on the screen, and then come back to the video. Okay, you should see there is a sodium ion right here on the left. Sodium has 3 energy levels. The first one has 2 electrons, second one has 8, and the third one only has 1 electron up here. Remember, the third energy level has to have either 8 or 18. It does not have enough electrons to share and create a covalent bond. So instead, it's going to create an ionic bond. It's going to transfer those electrons. Chlorine has 3 energy levels as well. The first energy level has 2, the second has 8, and the third has 7. Remember, the third energy level either needs 8 or 18, so it has one open spot here that needs an electron. Could chlorine share electrons and create a covalent bond? Yes, it could. But in this case, we're going to create an ionic bond because sodium doesn't want this one. It doesn't want to have to find all these spots. Instead, it's just going to say, hey, I'll give you this electron. It transfers that electron over, and we now have 2 charged ions. Because sodium lost an electron, it became positively charged. That's why there's a positive right here, and that's why you write it Na+. That's sodium with a positive charge on it. Chlorine gained an electron, so it now became negatively charged. That's why it says Cl-. That's a negative charged ion. You'll probably notice right here that it says chloride instead of chlorine. This is what happens when we write in the form of an ion. It becomes chloride instead of chlorine. Chloride ion is negatively charged. That negatively charged chloride ion is now attracted to the positively charged sodium ion. Opposites attract. They're like a magnet. They're going to bond and create that ionic bond between them and form sodium chloride, which is salt, NaCl. That is the end of the notes. There is a summary question down at the bottom of the notes. It says, how are ionic and covalent bonds different? How are they similar? Please take a second to answer that question. I might be checking that on the Check later on this week.